Today, we're diving into one of the most mind-bending ideas in physics, Einstein's twin paradox. Imagine being able to age slower than your identical twin. Sounds impossible, right? Well, that's the reality when you take a trip at nearly the speed of light. Let's find out how. But first, do not forget to leave a like and subscribe to Stellar Stories if you want to know more about physics and astronomy. Now, let's start. Picture this. We've got two identical twin astronauts, Alex and Casey. On their 20th birthday, they decide to take part in an epic space experiment. Alex will stay on Earth, but Casey is headed to a distant star, 10 light-years away, in a spaceship that'll zoom through space at 86.6% the speed of light. Pretty fast, huh? The big question they have is, what happens when Casey comes back? Will they still be the same age, or will something strange happen? Now, we know light travels at a fixed speed, so you might think Casey's journey would take 23 years round trip. 10 years there, 10 back, plus a little extra. But hold up, that's not quite right, because we've got to bring in Einstein's theory of special relativity. Here's where things get weird. The faster you move through space, the slower time passes for you compared to someone standing still. Yep, time itself slows down. This is something we can measure with an equation called the Lorentz factor. At 86.6% of light speed, time on Casey's spaceship will tick twice as slowly as it does for Alex back on Earth. Now here's the crazy part. While Casey is zooming through space, they won't notice time slowing down. Everything around them, their ship, the clocks, their heartbeat, will all feel totally normal. To Casey, it'll be just like living a regular life. The only one who will notice a difference is Alex, who's back on Earth in what we call an inertial frame, not moving relative to Casey. From Alex's point of view, when Casey gets back, they'll have aged less. But here's where it gets tricky. Because motion is relative, Casey could flip the script and say, wait a second, what if I'm the one standing still in my spaceship and Alex is the one moving away from me? Doesn't that mean Alex should be the one aging slower? This disagreement is what's known as the twin paradox, but it's not really a paradox. It's just a misunderstanding of relativity. So how do we resolve it? To test it out, the twins agree to send each other a light signal every year. The speed of light never changes, so the signals will show how time is passing for each of them. From Alex's perspective, they'll be on Earth for the full 23 years, but when they send that first signal after 1 year, Casey won't receive it right away. Since Casey's speeding away, it'll take over 7 Earth years for the light to catch up with them. But on Casey's end, only 4 years will have passed. Then on the way back, it gets even weirder. Since Casey is now heading towards Earth, the light signals will reach them more frequently. Casey will observe Alex aging much faster as they close in. For Casey, the entire trip will seem much shorter. Thanks to an effect called length contraction, it'll feel like the distance between the star and Earth has shrunk. From their point of view, the round trip will take only about 11.5 years. When the twins finally reunite, Alex will have lived 23 years, while Casey will have only experienced 11.5 years, meaning Alex will be 43 and Casey will still be 31. Crazy, right? So what caused the difference? While Alex stayed at rest the whole time, Casey's journey involved a big change. They accelerated, turned around, and then headed back. That change in direction means Casey wasn't always in the same reference frame, unlike Alex, who stayed on Earth. This is what breaks the symmetry and explains why Casey ends up younger. And there you have it. The twin paradox isn't really a paradox at all. It's a perfect example of how Einstein's special relativity works in the real world, showing us that time and space are more flexible than we ever imagined. If you enjoyed this journey through space-time, be sure to like, subscribe, and hit the notification bell so you never miss an episode of Stellar Stories. Until next time, keep looking up and wondering about the universe.